Great, there we go. We'll be looking at objective 1.3, which is to define the terms mass number, isotopes, relative atomic mass, and relative isotopic mass. Um, okay, so I have a few questions. The first question is, Liana, what do you think is the importance of the protons to the atom? Liana, can you hear me?
Sir, it helps to bind the nucleus
Okay,
together.
helps to bind the nucleus together. That's what Liana is saying. Uh, Shannon, what do you think is the importance of the protons to the atom?
Well, we know the protons are positively charged, and I would say that the protons it helps to keep the atom stable.
All right. Marissa, same question. What do you think is the significance of the protons?
The protons, ooh, they combine with the electrons and neutrons to make atoms. I really don't know.
It's fine. It's fine. Whatever it is that you think, you just say, right? That's why we're here to learn.
Right.
Jamal, what do you think is the significance of the protons? Jamal? Oh, sorry. Oh, apart from speaking, you can also type in the chat and I'll just look there and convert it and I'll vocalize it rather for you. So Jamal is saying to bind with the neutron. All right. Okay, so anybody else wants to give it a try before I say what I think or what the significance of the protons is to the atom?
I would like to add to what everyone said. Basically, a very important role of the proton would be to determine the atomic number of the element.
Okay, to determine the atomic number of the element. All right, so that's what it can be used for, right? It can be used to determine the atomic number. But the significance of the protons, right? The significance of the protons is that the proton is the identity of the element, right? The proton is the identity of the element. And what that means is that it is the proton number, which is also called the atomic number, right? The proton number or atomic number that really tells us what element it is that we're dealing with. To be a bit more specific, if we have an atom and that atom has 6 protons, then the atom belongs to the element carbon. And any element or any atom that contains 6 protons is always going to be the element carbon. Excuse me. Jamal is saying that I'm breaking up. Does anybody else um, get that, or are you guys hearing me clearly and as well seeing on the screen?
You're seeing on the screen, but you're breaking up 1 and 2 times.
But is it okay? Is it enough you're getting for me to go on, or is it
Yeah,
just
yeah, yeah.
Yeah, I
It's
can
enough.
understand. Mhm.
okay? Jamal, is it okay with you? Is the breaking up affecting you greatly, or you're able to follow? Okay, and Devin, you said you're also I'm also breaking up. Can you follow? All right. So continuing, like I mentioned, the proton is the identity of the element. It is what tells us which element it is that we're dealing with. And every element has a unique proton number. No two different elements can have the same number of protons, right? So we can never have an element of nitrogen having 6 protons. 6 is the defining proton number for the element carbon. 7 is the defining number for the element nitrogen. And so therefore, if the proton number changes, if the proton number changes, then that tells us that the element itself changes, right? The element itself changes. All right, that's for proton. What about the neutrons? What's the importance of the neutrons? You can type in the chat, you can answer as well. Amy, what do you think is the importance of neutrons? Oh, go ahead, Marissa, because I
Oh,
know she's you on me.
it's required for the what you call the stability of the nuclei.
Okay, stability of the nuclei. Um,
That makes
okay,
sense.
yeah, it does make
Yeah.
sense. But to you, what does that mean?
Uh, well, let me get back to the one. We can get back to the one. Don't worry.
Okay, okay, sure. Nuclear stability. It's correct, but what exactly does it mean? Have you ever wondered? Go ahead, Shannon. Go ahead.
My opinion is that the what she's talking about is like it's like a energy that holds the nucleus together.
Interesting. It holds the nucleus together. Absolutely. But uh, to be more specific again, this is why. Have you ever wondered that protons, right? Each one is positively charged, and they're located in a small space, not around an entire big sphere as Thomson proposed, but rather in a small dense area which we call the nucleus, and each one of them is positively charged. Don't you think that there is a tendency that they will repel each other, right? They're going, the force of repulsion among the different protons in the nucleus will cause the protons to repel each other. And so therefore, that's where the neutrons come in. When we talk about nuclear stability, we really mean that the neutrons go in between, they force themselves between the protons, and they prevent the protons from repelling each other and pushing each other out of the nucleus. So the protons, positive as all of them may be, and want to repel each other, do not do so because the neutrons that are found between the protons or among the different protons present in the nucleus is what holds the nucleus and all of the protons together. That is what nuclear stability means, right? That the neutrons are present to prevent the protons prevent protons from repelling each other. Is that clear?
Yes,
Yes,
sir.
sir.
All right, that's clear. What about electrons? What is the importance of, another thing before we move on. What happens, so if the proton number changes, the element itself changes. For example, if we have 6 protons, the element is, this implies that the element is carbon. But if we have 7 protons, this implies that the element is nitrogen. What happens now if the neutron changes, but not the protons? What do we get then?
Would it be an isotope?
That is correct. We have isotopes. Isotopes have different numbers of neutrons. So we can have the element carbon with 6 protons and 6 neutrons. That is what allows the atomic number, the mass number here to be 12. And this is carbon 12. If we have 6 protons, remember this is the identity, it is still an atom of carbon. But if we put 13 at the top here, it means that the number of neutron here is now 7 instead of 6. So to get the number of neutron, it is the top number subtract the bottom number. So this is telling me here that we have 6 neutrons. And this is telling me here that we have 7 neutrons. These two things are called isotopes. All right? Now, for the electrons, what is the importance of the electrons to an atom? Anybody?
To determine how the element reacts with another element?
That is absolutely correct. Elect
Isn't
Go ahead, go ahead.
the electrons important for the bonding?
Absolutely. And bonding really is used to determine the type of reactions that the element
Right.
can participate in, right? So the electrons determine the chemical properties, all of that you mentioned, type of reaction that it can take part in and the bonding and so on. All of that is related to this general thing that we call chemical properties. More specifically, the valency electrons, right? What are the valency electrons? Those that are located where?
Electrons in the last shell?
In the last shell, right? So what we expect then is that elements that have the same number of electrons in their outermost shell are going to react similarly with different reagents, different other reagents. And elements that have the same number of electrons in the outermost shell are found in the same what of the periodic table? Anybody? Electrons, elements with the same number of electrons in their outermost shell are found in, that's correct, Marissa. They're found in the same group of the periodic table, right? Found in the same group of the periodic table. Now, while electrons determine chemical properties, the mass number, which is really equal to the number of protons plus the number of neutrons, this determine the physical properties. Determine physical properties. So just to be clear, sorry about that. Just to be clear, chemical properties relate to the type of reactions that the element can participate in. Reaction with water, reaction with nonmetals, reaction with dilute or concentrated acids. Any type of reaction constitutes a chemical property. Whereas physical properties would be things like melting and boiling point, solubility, density, mass, and so on and so on. Right? Those are what chemical and physical properties are. Okay. So do you guys have an understanding now of the importance of the three subatomic particles to the atom?
Yes, sir.
Okay, great. Any question or comment or so before we move on? Kiana, anything from you?
Sorry, I understand.
You understand? Okay. Lamar, let's hear something.
Yes, sir.
Great. Thanks, Liana. Anything from you, Lamar? Excuse me. I know Lamar has indicated that his net isn't working properly, so I want to know if he's following. Of course, yes, Marissa, definitely. Marissa is asking that we do a recap of the importances. Oh, it's right here. Excuse me. I'm gonna take it off of the screen, and we'll have excuse me, sorry about that. We'll have different persons talk about the importance of each, right? So I've just removed everything from this screen. Who would like to tell us about the protons? Everything that you just learned about the protons.
The protons is the identity of the element, and the proton is also the atomic number. And if the protons change, the element also changes.
Thank you, Kiana. And also, Kiana, can two different elements have the same number of protons?
Yes.
No, sir.
Remember, your identity is really what sets you apart from another person or from every other thing, right? So, Jamal, can you just mute your mic? So no two elements can have the same number of protons, right? That is what it means to be the identity of the element. Thanks, Kiana. Can someone please recap the importance of the neutrons and explain to us some stuff about that?
This is Lamar.
Yeah, hi Lamar, go ahead.
So the neutrons, they help with the nuclear stability of the atom, and nuclear stability basically means the neutrons, they go between the protons, preventing them from repelling each other.
Absolutely. Thank you very much, Lamar. And the electrons. Can somebody tell us the importance of the electrons?
Okay, good night again, everyone. So the electrons basically determine the chemical property of the atom, meaning how they react with another atom, another element then. And the atoms with the same number of valence electrons, they belong to the same group as well.
Thank you, Vish. And that means that they are going to react similarly with each other, right? And then can somebody tell us what determines chemical properties and then give us some examples of physical properties, and then can you give us some examples of physical properties?
Mass number is basically the sum of the number of protons and the number of neutrons, and this determines the physical properties. Properties of an atom such as density, mass, yeah.
Thank you very much, Shannon. Also solubility, melting and boiling points, and so on, right? Yeah, so are we okay then with that recap of the importance of the different subatomic particles to the atom? You can just indicate
Yes,
in the,
sir.
you can
Yes, sir.
speak and then you can also
Yes, sir.
indicate in the chat, right? Marissa, are you okay with that? All right, great. Yeah, I noticed that I'm breaking up again for you, Marissa, but hopefully the recording is available and you can take a look at it, right? Um, all right, so we're getting into now what we want to talk about, and that is or perhaps we should not. I think this is going to be a good place to stop for tonight. I really want to get into this, but then because of the Wi-Fi,
Sir, before we close, I have one request.
sure, go on.
Could you please go over mass number again, the meaning of it?
Well, that is what we're actually supposed to be looking at as the next thing. I didn't want to, but do you think that the Wi-Fi is working well enough for us to cover it, or shall we do it tomorrow? Because remember, we have to meet face to face tomorrow at 8:30.
Time to do it out now.
Let me just get some feedback from Porcin.
Sir, I'm okay
Lamar is okay, Fish is okay, Marissa is
with
okay.
doing it.
Devin, Devishkar, Jamal, Liana, Shannon,
Yes,
what?
sir.
All right. Let's cover it tonight then. So
Yes,
this
sir.
is the
I
question.
agree.
All right, great. So Devishkar, while you're here, what is the mass number of carbon?
Yeah, I'm okay.
Anybody?
So the mass number of carbon is 6
No, that's not
and the
mass. That
relative
is
is
the
12.
number of protons. That is the atomic number.
No.
Anybody? What's the mass number of carbon?
Sir, would it be 12?
Okay, Vish is saying 12. Amy, what do you think? Amy is saying 12. Liana, do you agree that the mass number of carbon is 12? Okay, Liana agrees and Jamal is also saying 12. Now, that is not totally correct. And it is not totally correct because the definition for mass number, right? It is the number of protons plus the number of neutrons of an atom, a single atom of an element, That is what the mass number is. It's the number of protons plus the number of neutrons of an atom of an element, a single atom. Now, the question that I just asked is, what is the mass number of carbon? And you know what this is similar to? We go to a supermarket and I say, how heavy is the potato? And then the question you will have to ask me then, which potato are you talking about? Carbon comes as carbon 12, carbon 13, and carbon 14. Right? It comes as carbon 12, carbon 13, and carbon 14. And so when I say what is the mass number of carbon, you're supposed to ask me, sir, do you want the mass number of carbon 12, carbon 13, or carbon 14? And respectively, the mass number of carbon 12 is 12, carbon 13 is 13, and carbon 14 is 14. Now the reason why protons and neutrons, you add those two to give you the mass number and not electrons, is if we go back to our table, we see that proton has a mass of 1 and a charge of positive 1. Neutrons have a charge of 1 and, a mass of 1 and no charge. And electrons have a mass of 0 and a charge of negative 1. So the top value is the mass, the relative mass. And if we are to add electrons, the masses are so small that we assign 0 to them, so they would not even count. Hence, mass number is given as number of protons plus number of neutrons. Now remember, because each proton has a relative mass of 1, if you have 13 protons, that would just give us a mass of 13 and 13 units, as we call it, 13 units, right? Now, if I give a question and I say that an atom of an element has 6 protons, 6 electrons, and 6 neutrons, what is the mass number of the element? Be careful, electrons do not count when we check the mass numbers. So it is not 6 plus 6 plus 6. It is not 18. It is just 6 plus 6, which is going to be 12. Right? So the thing about, again, mass number is that it applies to an atom of an element. And for those atoms that have isotopes, if you want to find the mass number, you need to specify which isotope it is that you're talking about. So to complete the question, what is the mass number of carbon? This question is incomplete. I can put carbon 13 here. Then when you say 12, that would be incorrect, right? The mass number of carbon 13 is actually 13. That is the answer. So the way we represent that is that we have the element here, X. We have A, which represents the mass number. And we have Z, which represents the atomic number. So in an element such as sodium, which is the 11th element of the periodic table, and it has a mass number of 23, right? This here is the number of protons. This here is the number of protons plus number of neutrons, right? The smaller of the two numbers, usually the bottom one, represents the number of protons, and the top number represents the number of protons as well as the number of neutrons. And so therefore, if you want to find the number of neutrons, which we call n, it's going to be equal to the top number, subtract the bottom number. Right? If the number of neutrons is equal to the top number, subtract the bottom number. So in this element sodium, we can say that sodium has 11 protons because this number at the bottom here is 11. It has 11 electrons because the number of protons is always equal to the number of electrons. The number of protons is always equal to the number of electrons. And it has 12 neutrons. And why is it that it has 12 neutrons? Top number, 23. Subtract the bottom number, which is 11, gives us 12. That's how we determine each of the number of subatomic particles given the chemical symbol for the element. Again, to recap. When you have an element and you have two numbers, the bottom number usually, or the smaller of the two, is how many protons there are in an atom of that element. So there are 11 protons because 11 is the bottom number or the smaller number. Number of protons is always equal to number of electrons. So therefore we also have 11 electrons. And then to find the number of neutrons, it is the top number subtract the bottom number. 23 subtract 11 is 12, number of neutrons. Now, if we have to write this atom here, right, as Na, is it Na11 or is it Na23? What do you guys think? Do we write it as sodium 11 or do we write it as sodium 23? Amy?
Sir, I think it's 11.
Amar is saying 11. Devin is saying 23. Let's have a discussion around that then, since we have a difference of opinion. Let's hear from other people. You can talk or you can text.
Sorry, depends how the question is asked. If you ask for the atomic number, then it's gonna be 11. But if you ask for the mass number, it gonna be sodium 23.
Okay. Any other comment or so? We still have to figure out what it is. Is it correct to write 11? Is it correct to write 23? So this is what we have so far. Lamar is saying that it's 11. Devin is saying 23. And then I think it was Devishkar just now. Somebody else said that it depends. It could be 11 or it could be 23. So Shannon is saying that it is 11. Amy is saying that it is 11. Let's hear from everybody else. Liana, is it 11 or is it 23? Liana is saying that it's 23. Vish, is it 11 or
I
is
said, I said 23 as well.
23 as well?
Okay, that's how we did it before.
Right. So the correct response is that it is 20. And it is 23 because writing it as Na11, right? First of all, it is redundant. Remember we said that the reason, in fact, why you specify this number here, 23, as in the case of carbon, is that carbon could have been 12, 13, or 14. That is why you needed to specify the number. Secondly, if we're writing this here as really the number of protons, we don't need to do that. It is understood, and it will always be understood that sodium, any sodium atom will have 11 protons. We never would have to specify that. What will change for the sodium atom, because we have different isotopes, is going to be how many neutrons it has. And so the format that we use is always the symbol of the element followed by a number. So this here is the symbol, and the number that follows is always the mass number. So given that this here is the format, X followed by a number, and the number has to be the mass number, when we look at that element sodium, right? Sodium Na1123, and we have to convert it into another notation. We write it as Na, and then we said the number that follows has to be its mass number, 23. You never have to specify the number of protons when you're writing an atom. We'll never have to write Na11, because you cannot have, if this here represents the number of proton, you can't have Na12, right? As soon as this number changes to 12, this thing now becomes the next element, which is magnesium. Is that clear for those persons who say that we use 11? Why is it that we're not using the number of protons? Shannon?
Yes, sir.
Amy?
Alright. It's
Wow. Okay. Understood. Great. Right? So again, to recap, the two notations that we're using. The first notation is that we write the symbol for the element. We put the number of protons and we put the number of electrons. Sorry, the mass number. And the second notation, we write the symbol for the element followed by its mass number. Sometimes we can even just write Na23. And it's understood that this number at the bottom here is 11. Because sodium, the atomic number of sodium, cannot be any other value. It has to be 11. So we don't even have to specify anything at the bottom there. Right? We don't even have to specify this. So these are three different ways in which we can write the notation for a symbol, or for an element rather. Now, two other things. First one is that, do you know what the mass number is also called? Mass number. Do you know what the mass number is also called? Anybody? Any idea or no idea at all? Devin, do you think you know another name for the mass number? No. Vish?
Sir, maybe we can say the
For the
atomic
nuclear
weight.
number,
Okay, we have two persons speaking
the
there.
nuclear number.
Vish is saying nuclear number, and Liana is saying the atomic weight. What?
Shannon said atomic
Shannon.
weight.
Okay, so the correct one is that it is called the mass number is also called the nucleon number. Do you know why?
Because of the combination of the proton and neutron,
And the
and
proton,
it is found in the nucleus.
absolutely correct. It's called the nucleon number because if we look at the structure of the atom again, we have the protons and the neutrons in the nucleus, and then we have the electrons orbiting, and the mass number is found by just adding those two components, those things that are found in the nucleus and not in the shells. And as a result, we can call the mass number the nucleon number. So thank you for that, Vish. That is absolutely correct.
No problem.
Is that clear, Devin? Great. And just something that I remember. So you'd find me often going back and forth because all of these things I don't remember all of them immediately, but as we talk about them and my memory returns, I will discuss them. We said that when the proton number changes, the element changes. No two elements can have the same proton number. We say when the number of neutron changes, we end up with isotopes. Same element, but different mass number, different number of neutrons, isotopes. And then we didn't even talk about what happens when the number of electrons changes. So what happens if the number of protons doesn't change, the number of neutron doesn't change, but the number of electron changes? What do we end up with?
Would it form an ion?
That is correct. Let me go back to the chat. Vish is saying that, right? When the number of electron changes, we end up with ions. Our cations and our anions. Proton changes, element itself changes. Neutron changes, we end up with isotopes. The element does not change. Electron changes, the element does not change, but we end up with ions. So I'll give an example here. The example is we can have the element calcium. And if calcium loses 2 electrons, it becomes the calcium 2+ ion. Same number of protons and same number of neutrons. Both of them have that. But this calcium has 2 less electrons than this one here. The ion calcium has 2 less electrons than the atom calcium. But they do have the same number of protons and they do have the same number of neutrons, right? Okay, so we'll stop here for tonight, but just to recap something else. If I have an element and that element is magnesium here and another atom. So I have an atom of magnesium and another atom of magnesium. In terms of protons, neutrons, and electrons, definitely, what do these two have to have in common? They must have the same what? Number of what?
Sir, can you please repeat the question?
I have a magnesium atom and another magnesium atom. So definitely, they must have the same number of what? Marissa is saying protons. Jamal is saying
I agree.
protons.
It's the protons as well.
Protons.
Protons.
So do all of us agree? And why is it that they must have the same number of protons?
Because the number of protons is constant. It doesn't change.
The number of protons is the identity of the element.
Okay, so I have two responses there just now. And although both are correct in what you're saying, they do not answer the question, you know. Jamal's response answered the question. So one of you is saying that the number of proton is constant, it doesn't change, and the other one is saying that the proton is the identity of the element. But you got to be able to relate what you learned to the specific scenario that is given. We're talking about two magnesium atoms, the same element. And once the elements are the same that we're talking about, then this magnesium atom must have the same number of protons as this magnesium atom. So you're correct, they must have the same number of atoms. Now, if this one is magnesium 24, and this one is magnesium 25. In terms of protons, neutrons, and electrons, what is definitely different about them? They have what? Different number of
Neutrons.
okay, right? Lamar? Amy, what do you think?
Different number of neutrons.
Absolutely, that is correct. Kiana is also saying, Devin is saying, Jamal, everybody is saying they have the different number of neutrons. Great. So at least you understand now the whole idea of mass number and the significance of the protons, neutrons, and electrons. But still, we have not completed all of the parts of the subjective of it as yet. But that's fine. Once we understand what we're learning, right? We don't have to rush. So this is it, guys, for tonight. I'll see you tomorrow at 8:30. Remember that we have a quiz tomorrow, and that quiz covers objectives 1.1 and 1.2, which would be these objectives here, right? These objectives are what the quiz covers. It's for 10 marks.
Okay, sir.
Any final question?